Hey everybody, welcome back to the show. Well, he is definitely the most interesting man that we know.
Absolutely. Buckle up because you will learn something despite yourself. Jaymie Matthews, UBC Professor of Astronomy and Astrophysics joining us, and also the best dressed man of the new year.
Jaymie, where on earth did you get that sweater?
This is actually a Toddland sweater that I found upstairs at Urban Outfitters.
Now, I have to say, when I saw the sweater, I was a little bit disappointed because you usually have talking shirts or shirts with musical instruments, but you're not going to disappoint today?
Well,
it's a double ender?
Well, I do have.
There's layering in effect.
There we go. We got my Lucasfilm Darth Vader shirt. If I can, there we go.
And we're not even going to talk about the fact that there's a Mexican wrestling mask in his pocket. Anyway, you are not here to talk about your wardrobe.
Stay thirsty for knowledge, my friend.
Yes,
excellent.
We're talking about life, I guess, and life outside of our solar system, outside of our planet.
That's right. We're the first generation of human beings in the history of our species to be able to look for life elsewhere in the universe. And part of the way you look is to find out where they might live.
So
searching
looking for other planets and the like?
That's right, exactly.
How do you look for other planets?
Well, you'd think the simple way would be to take a picture of a planet around another star. What we're seeing here is a lighthouse beacon shining right into your eyes. And think of that as a star like the sun. And there's a planet like the Earth that you're seeing only by reflected light there, and you can't see it, but there's actually a flashlight in that picture. And if we cut to the next image, then we turn off the lighthouse beacon,
you can see it,
and there it is. Now, in reality, we look at the next image, you can see before and after. Essentially, aliens, if they were looking for the Earth in photographs of the sun, they'd never see it because the sun is 1 billion times brighter than the Earth, and the Earth is hidden in the glare.
Tucked in the glare.
So the way astronomers started to search for planets, using a technique, by the way, that was pioneered right here in British Columbia at UBC and UVic, so it all started here, is based on the fact that stars and planets, it's like dancing with the stars, literally.
How?
Well, let me demonstrate.
Okay.
Now, you're the beautiful dance partner, but Mike, let's go for
But we need somebody that you can get some velocity happening with. So you're going to demonstrate with Mike. And what is it that you're demonstrating, Jaymie?
There's something we call the Doppler wobble technique. In terms
Doppler wobble technique.
I'm going to be a star.
Okay.
So
you're
I'm the
a star.
And you are going to be a planet that is so small and insignificant that you can't be seen.
I'm sorry, did you just say he's small and insignificant? I've been saying that for years.
Now, we're going to do a swing dance. Okay. Swing your partner round and round in an orbit, you are bound. And imagine that you couldn't see Michael. He's an invisible planet.
Insignificant.
You can see me because I'm a bright star. And as we're dancing, we're both going in an orbit. You're going in the bigger orbit because you're less massive than I am.
Right.
And I'm in a tiny little loop as I'm swinging around. And that's what happens with stars as planets orbit around them. They are forced to wobble. And if you can make
pick up the wobble.
Very careful measurements, you can see the wobble. So even if you can't see the planet, you know that there's a planet there. You can figure out how big its orbit is, what its year is like, what its orbital period is like, and a limit on how massive it is, how big it is. And so that's how, of the 519 planets we know of around other stars as of this morning,
just
most
in case somebody found one in the last couple hours?
That's right. Hey, it's an exciting time. The discoveries are coming hot and heavy, but most of those were found using this technique. And so when we're looking for planets around other stars, that's one of the ways we look for them.
And we're always looking for other planets because we want to live somewhere else. We want to inhabit somewhere else.
No, what we want to do is we want to pillage this one and then move to a nice neighborhood.
Well, that's a good point, because people think that we're looking for planets to find some place to evacuate to in case we screw up this place. But the unfortunate truth is that our ability to screw up this place, we can do that much faster than we'll have the ability to go to another planet. The nearest planet around another star that we're aware of is 20 light years away. And even at the speed of light, it's a one-way trip, 20 years long. And we've sent 12 people to the moon. We haven't sent a single person to Mars. let's forget about sending 6 billion people to another star
system. We're a long way away from that.
So the reason why we're looking for these other planets and habitable planets is, one, to teach us more about our planet, the Earth, and our star, the Sun, so that we don't screw up this place, to become better tenants of this particular condo, cosmic condo. We need to study other planetary systems to be able to better understand how our Earth is changing.
Well, and as you're finding all these other places, the realization that this is a very special orbit, we're in a very special spot amongst, you know, in our solar system.
Perfect point. What we're looking for are planets that might support life. And the search for life elsewhere in the galaxy is a fairy tale. So the fairy tale is not Goldilocks and the Three Bears, it's Jaymie and the 3 planets.
And away we go again.
There we go.
We can tell the story starting here at home in our solar system. So let's start in our solar system and take the planet Venus.
Okay.
Beautiful name. Goddess of love.
Yes, I am.
Sister planet, you are indeed. Sister planet to the Earth, sister world to the Earth, about the same size, the same mass, and it should be a nice place to live, but it's a living hell. The temperature on Venus is higher than the melting point of lead. And runaway greenhouse effect, the most extreme case of what some people are worried could happen here on Earth. Because Venus is too close to the sun, it's too hot for liquid water for oceans to exist.
Okay, so then
we go to Mars. When you think of Mars, so, you know, everyone thinks of aliens, they think of Martians. Yeah. But if you go to Mars, it's not really a vacation spot. It's cold, the air is thin.
Send air, water, and heat.
It's too cold. Too far away. So everything's frozen. The water exists in polar caps or in kind of a Martian alien permafrost in the soil.
So we wouldn't do well there.
Planets, we've got too hot, too cold.
And then we go to the Earth. And the Earth is just right. The temperature, the average temperature of the Earth at the surface is about 15 Celsius, actually pretty close to today's temperature right now. And it's just right. And so it's in the zone. It's in what we call the habitable zone, or the Goldilocks zone, where the temperature is between the freezing point and the boiling point of water. Now, it's kind of like thinking of the sun as a campfire. If you're too close, it's too hot. If you're too far away, you're freezing. But at the right distance, you're comfortable.
Just right.
So does the habitable zone, does the size of the sun or the star affect the habitable zone? I mean, obviously, right?
You should be, should be teaching some of my classes.
You should be wearing a Mexican wrestling mask.
I thought about astrophysicists.
Beauty and brains all in one comment. Wow, it's just a great. So yeah, the thing is we tend to be kind of sun-centric, Earth-centric. When we think about life, we think about the conditions here. But it turns out that in our galactic city, the Milky Way galaxy, the citizens are very different, like they are in the city of Vancouver. And so not all stars are like the sun. And there are stars that are much dimmer than the sun. And one of them that we've been studying in the last few years is called Gliese 581.
Beautiful name, Gliese.
A name only an alien mother could love. Gliese is the name of the German astronomer who first cataloged these particular stars. And it's a star which is puts out only about 1% of the energy that the sun does. So instead of being a stellar campfire, it's a stellar match. So and you got to huddle really close to it to stay warm. And astronomers have found a number of planets around it, and one planet called Planet G, we're not very imaginative about naming planets, might turn out to be in the habitable zone. And if it is, if that planet really does exist, and there's some controversy about whether it exists, but if it does, it would be the first planet that we've ever known of outside our solar system, beyond the Earth, that is in the Goldilocks zone. The question is it turns out that the people who've found the first 4 planets around this star in Switzerland, they can't find this one in their data. So stay tuned.
So everybody out of the ship, we're not going to Gliese 581 G yet.
That's right. So it's either a Goldilocks world or a Cheshire Cat planet. Now you see it, now you don't.
Well, thank you, Jaymie. Always a pleasure.
I see things on the couch. I wish we had time.
Just put them on, because next up we're going to have you back soon to talk about why the heck the sky is falling with birds and fish and stuff. But we can all be safe knowing that this man is in charge of finding other places to live
long
in this planetary system.